Hey everyone, it's Mrs. Brimlow, and today we're going to talk a little bit more about solving equations with variables on both sides algebraically. So if you have the copy of these notes from yesterday, if you could take those out, or you can print a new copy, or you can just watch the video and then do some practice afterwards. So just as a quick review, yesterday we used a balance scale and then some manipulatives to visually and physically see how you solve equations, how that works, how do we keep it balanced. And we started by looking at some two-step equations, and then we stepped it up a notch and looked at our equations where we had variables on both sides. So you can just see from yesterday, for example, the first problem we did was 3x plus 8 equals 14. So we just had one variable term. But here we have a variable term on each side. Okay. So really, when we're solving these types of equations, variables on both sides, there's really only one extra step we're taking to solve them. Okay. And so we're going to talk about that a little bit more today algebraically. And we're going to be doing that using the third page. We're going to skip these two questions for now, and we're going to go ahead and work here. Okay. Now, when we were working with these problems yesterday, we did not encounter negative numbers. However, it's eighth grade, and that's the expectation. So it's really important that, as helpful as the balance scale or those tools can be, there's nothing wrong with using them. We want to be able to become more confident and comfortable using our algebraic skills to solve these equations. So I'm just gonna... Now, when you approach these problems, there are multiple ways you can solve them. I'm going to show you two different methods to do that. Okay. So you're going to notice there is the same exact equation here on both sides. Okay. So really, we're just going to solve it one way, and then I'm going to solve it another way so you can see how you can approach it from whatever way makes sense in your brain. Okay. So as we did yesterday, just kind of naturally with the sticky notes, I prefer method one. I'm actually going to put a little star next to method one. This is my personal preference and what I will suggest to you. But once again, if you follow the steps, you can use either method. So what I like to do is start with my variable terms and get those settled. And how I do that is I start on one side and see which one, or I have to look at both sides, but I look to see, okay, this term is negative 8x, and on the other side is negative 5x. Whatever the smaller one is the one I'm going to get rid of and move. Now, in this case, because we're talking negatives, we always take the sign in front of the terms. The negative 8x is the smaller one. So I'm going to go ahead and box that because that's the one I'm going to get rid of and deal with first. Okay. To do that, I use my inverse operation. So I'm going to add 8x here. Okay. That means they go away. And what I do to one side, I have to do to the other. So I'm left with 13 here. Negative 5 plus 8. Be careful, those are different signs. So I like to ask myself with different signs, do I have more positives or negatives? Well, I have more positives because I have 8 positives versus 5 negatives. Well, how many more positives is that? And the answer is 3. So I'm left with 3x here, and I'm going to bring down that 4. We haven't done anything yet. Okay. So now I have a two-step. Okay. So now my goal is to get this by itself. So I'm going to start by subtracting 4 on both sides. Okay. Think of these like the little cubes or the circles. So I'm left with 9 equals 3x. And now I'm going to divide each side by 3 and see that my variable or unknown is also equal to 3, just by chance. Okay. So once again, really there's just one extra step we add in here, and that is moving one of my variable terms, getting rid of it, just as we would our constants. Okay. Now method 2, really there are more methods, but this is the second method I'll show you. Instead of starting with your variable terms, you could start with your constants like we've always learned to do. And I'm going to use that same method. I have 13 on this side, 4 on this side. 4 is the smaller one, so that's the one that's moving. Okay. So I'm going to subtract 4 from both sides. So I get 9 minus 8x. I need to make sure to bring all the signs down, especially ones that weren't affected, equals to negative 5x. So now you can see I've got my constants all together on one side, which is 9. Okay. So next, I need to get my variable terms together. So what I need to do is, since all my constants are on this side, I need to get all of my variables on this side. So I'm going to add 8x to both sides. So that leaves me with 9 here. Negative 5 plus 8 is 3x. Okay. And then once again, we're going to divide by 3 and find that x equals 3. Okay. Same exact answer for the same exact problem, which is what we should see. And really, if you kind of take a look at the steps, instead of adding 8x first, we did it second. And instead of subtracting it 4 here second, we did it first. So we're really doing the same steps, just a different order. And we still got to the same answer. And that's really the cool thing about these equations is all of our brains think differently and see these problems differently and want to approach them differently. As long as you're showing your work using these inverse operations, as that is the expectation, you can start anywhere you want that makes sense to you. Once again, I would suggest method 1 to anyone solving these, but method 2, or instead of starting with the smallest one, you could have subtracted 13 from both sides. You could have added 5x to both sides. The issue with starting with those numbers, the bigger numbers, is you have a higher chance of getting into negatives. There's nothing wrong with that, but if you're not as comfortable with that, we can't always avoid it, but a good way to do that is using your smaller numbers. So, but once again, my point here is you can start anywhere in these equations as long as you show your work and you're using these inverse operations, okay? And just to prove that these equations work, I'm going to replace x wherever I see it with 3 to show you that this equation is balanced. So I'm going to bring down the 13. Negative 8 times 3 is negative 24. Negative 5 times 3 is negative 15 plus 4. So 13 minus 24 gives me negative 11. Negative 15 plus 4 is also negative 11. So you can see that 3 is definitely the answer. It didn't matter which way we solved it. When we replace this back into our equation, our proof is right here that it worked. Okay. So today we're going to continue to do more practice. Once again, if you still need to use those manipulatives, when it comes to problems with negatives, it's not going to work as well. But if that's helpful to you or just to keep referring back, that's fine. But we really want to work towards doing our work just algebraically. And you still are expected to do it this way, even if you're still using those manipulatives as a tool. Okay. So if you have a question, let me know. If not, good luck with the work, and I will chat with you soon.